3, 2, 1, which is pages 16 and 17. Today we're only going to do page 16, and tomorrow we'll do page 17. Okay? So how can I solve inequalities? And the topic is solving inequalities with one or two variables. So by the end of the lesson, I will be able to extend what I've learned about solving equations graphically to solving one and two variable inequalities and systems of inequalities. Okay? So you guys are used to taking and let me move it over this way, taking an equation with an equal sign, and you have something on the left and you have something on the right. You're going to have a solid line or curve, whatever it is you're graphing, as opposed to these are going to have dashes or solids. And then this one, equations do not have shading, but less than or equal to, greater than or equal to is going to have shading. Okay? So these are red, less than or equal to, greater than or equal to. Okay? Those are our four inequality signs. Technically, an equation sign with a slash through it is also an inequality. But we're not talking about that one right now. Okay? All right, so here's what we're going to do. We're going to start with these two equations right here. It says solve the inequality graphically, and we're going to represent the solutions on the number line below. Okay? So in the middle of this inequality, we have this less than symbol. And one way to think about it, let me make it a little bit bigger. One way to think about it is it's less than, but it's not equal to. It's missing the equal part. Okay? That's going to help us with graphing. Okay? And it's also going to help us think about when we get to the solution. So the left side of the equation, the left side of the inequality I highlighted yellow, and the right side of the inequality I highlighted orange. That's how I'm going to graph them below. Okay? So the yellow side I'm going to highlight in yellow, the orange side I'm going to highlight in orange, so you'll see where the overlap is at. Okay. So yellow is going to be, the yellow has a square in it, so that's going to be our parabola. So our parabola is graphed here, has a shift 2 to the right and down 3, and then it has a compression of 1/4, so it's a little wider than the parent. Okay, that's the parabola. You can get that in Desmos if you need to, but most of you can graph that pretty well. And then the right side of the equation is linear. So this one crosses the y-axis at +2 and has a slope of 1/2, which is up 1, over 2, up 1, over 2, up 1, over 2. So it's going to be that line right there highlighted in orange. Okay, we want to know, when is the parabola less than or below, but not equal to the line? Okay? So here's your parabola. When is it below that orange, the orange highlighted line, but not exactly equal to? If you were going to type this into Desmos, you're going to graph the first linear or quadratic as 1/4 x minus 2 squared minus 3. And then type in the second one, 1/2 x plus 2. That's just your left and your right. Okay? So we want between when x is -2 and when x is 8. Okay, so if you look right here, their intersection is at the line x equals -2. That point right there. If you draw an arrow to it, that point is at 2, 1, which means, -2, 1. So that point would be -2, 1, and this intersection point would be 8. 8 what? 1, 2, 3, 4, 5, 6. Okay. All right. So we're going to do what's called testing some points. We need to plug in some numbers. We want to try one that's over in this area, one that's in the middle area, and one that's over to the right, and see if it's true or false. Okay? So let's try. I just want you to look at one at a time, sorry. First, we're going to try -4. Okay? Because the solution should be between -2 and +8, right? But not equal to. So we leave the open circle here, open circle here. We have open circles because we don't have the equal part right here, right? If you have the equal part, you're going to fill in the circles or the points. So we leave them open. Okay? And it's in between it. So we shade in between. All right? So let's check our points. So to the left of this point, you could try any of these numbers. You could try -3, you could try -4, you could try -5, you could try -100. You could try anything to the left of the -2. So I just randomly picked -4, okay? I didn't pick it for any special reason, just that it was to the left of -2, okay? All right, so we're going to plug in -4 into the full inequality that's back up here. So this one, we're going to plug it into here, plug it in for x right there, and plug it in for x right there. And we're going to see if it's true or false. All right, so 1/4 -4 minus 2 squared minus 3. Is it less than 1/2 of -4 plus 2? So then we're going to simplify using our order of operations. So you want to do the parentheses first. So -4 minus 2 more will get you -6. And then -6 squared is 36. 1/4 of 36 is 9. And then 9 minus 3 is 6. So we have 6. We want to know, is 6 less than whatever number we get on this side? So for this side, we have 1/2 times -4, which is -2. And -2 plus +2 is 0. So is 6 less than 0? No. So you say false. Okay? That's just to confirm that you shouldn't have shading over here. Okay? Now for the next number, we are going to pick a number that is in this shading, right? And you can pick any number, -1, 0, 1, 2, 3, 4, 5, 6, 7. You can pick any of those numbers and you should get what? Here we got false, so we should get true, okay? Let's try 0. If you ever have the choice to plug in 0, pick 0. 0 is usually easy, right? Because 0 plus 0 is 0, 0 times 0 is 0, 0 squared is 0. 0 often works out really easy for you. Okay, so we're going to plug in 0. So we have 1/4 of 0 minus 2 squared minus 3, less than 1/2 times 0 plus 2. So I'm going to do the left side of the inequality first. 0 minus 2 should be -2. That's wrong. 0 minus 2 should be -2. And then -2 squared should be 4. And then 1/4 of 4 should be 1 minus 3. There's an error. And 1 minus 3 is -2. Is -2 less than 2? There should be a -2 in here. There we go. Then we check the right-hand side of the inequality. 1/2 times 0 is 0. 0 plus 2 is 2. So is -2 less than 2? Yes, that one's true. Even with my error. All right, let's check one more number over in the right section. So any number that's 9 or greater. I randomly picked 10. No reason, no special reason, just that it was to the right, okay? Where there's no shading. So I do want to get false, okay? So we're going to plug in 10. 10 minus 2 is 8. 8 squared is 64. 1/4 of 64 is 16. And 16 minus 3 is 13. On the right side of the inequality, we have 1/2 of 10, which is 5. 5 plus 2 is 7. And we ask ourselves, is 13 less than 7? No, it's not. So we say false, okay? So we're saying false because there should be no shading here. True because there should be shading here. And false because there should be no shading there, okay? Any questions on page 16? Yes, sir.
When you're solving an inequality, the end goal is to prove that.
Is to prove that. Sometimes, and then sometimes it's just to graphically represent it. You can do it either way. So kind of both things. So you want to represent it graphically and algebraically, basically what we've been doing with even just equations. Representing them graphically, representing them algebraically. So both. Being able to go between the two.